Exporting a stratigraphic column based on a splice interval table in PSICAT is very similar to exporting based on section depths, which is explained in the previous tutorial, 7a. The main difference is the ability to include selected portions of a section, which requires the more complex splice interval table, or SIT, which we usually say SIT, format. For the purposes of this tutorial, we'll construct a SIT by hand. Typically, this is not necessary. Your SIT will be generated from a splice you built in a separate piece of software, most notably Correlator, which is part of the CoreWall suite of software maintained by LACOR CSDCO. If you already have a SIT and a corresponding PSICAT project, no tutorial is necessary. Just choose your SIT when prompted in the Export Strat Column dialog and export. If you want to understand the details of how to construct a SIT to export a strat column, keep on watching. The Splice Interval Table format looks like this. Each row of a SIT table describes a single interval that starts in a section and ends in that section, or a later section of the same core. So the first 4 columns will indicate the core in which the interval is defined. The next 4 columns represent the top of the interval. Top section is the number of the section where the interval will begin. Top offset is the section depth in centimeters of the top of the interval. And top depth CSFA and CCSFA are the total depth and composite total depth of the top of the interval, respectively. For the bottom of the interval, we have basically the same 4 columns, but they represent the bottom. So bottom section will be the number of the section where the bottom of the interval is. Bottom offset is again in centimeters, the section depth in this section where the end of the interval occurs. And bottom depth CSFA and CCSFA are the total depth and total composite depth of the bottom of the interval, respectively. The final 3 columns describe more information about the splice, but they will not be necessary for you to fill in any way. Splice type just determines how this row would relate to the next row if there was one. Data used is simply bookkeeping, as is comment. It's just a way to maintain some more metadata about the intervals. You will not need to worry about any of these. So this tutorial, we're going to use the same PSICAT project as we used in the previous section depth tutorial, 7a. It consists of 5 sections that come from 2 cores. These 3 come from core 1a. These 2 come from core, 1y. And these 2 cores come from 2y. Each of these sections is 1 meter in length. And I added fairly random lithologies and symbols to each of them just to have something interesting to draw, even though it may be scientifically very unrealistic. So we're going to start with the simplest possible example. We're going to construct a SIT with a single interval taken from the first section in our project, demo 4b, 1y, 1a. As I said, this section is 1 meter in length, but for purposes of this demo, we're going to create an interval that excludes the top and bottom 10 centimeters of this section. So we're going to draw everything from 10 centimeters here down to 90 centimeters here. So we'll go back to our splice interval table format here and start filling things in. So first, we're going to fill in the ID columns for the core that we're pulling from. So that is fairly straightforward. Our site is 4, our hole is B, our core is 1, and our core type is Y. So as you can see, we have to specify them separately. PSICAT will combine them to match the project section names. Next, we're going to provide information about the top of the interval. We want to start in section 1 at 10 centimeters. Again, remember that top offset and bottom offset are in centimeters, so we're going to put 10 here. And we're going to start our column at total depth 0, so we're going to use that value for both the CSFA and CCSFA columns. Now we need to provide the same set of information about the bottom of the interval. As we said, we want our interval to end in section 1 as well, so this is still 1. But we want to add 10 centimeters from the bottom of that section, which is a meter in length, so we're going to go with 90 centimeters there. And so cutting off the top and bottom 10 centimeters of a meter-long core gives us a core that is, an interval rather, that is 80 centimeters long. So we're going to do 0.8 meters as the bottom of our interval. So the length of our interval from 0 to 0.8 is going to exactly match the length of our the material that we're taking from this core, because it runs from 10 centimeters to 90 centimeters, or 80 centimeters, which works out to 0.8 meters. All remaining fields can be left blank, so you don't need to worry about splice type, data used, or a comment. And now we will save this file as a CSV, which is the required format to be passed into PSICAT. So save this as a CSV. Continue through that, so we'll hide Excel. And now, oops. Now let's export a strat column based on that sit table. So here's the table that I just created. Choose Open. And as you can see, just as with section data, the first thing PSICAT will do is match the sections specified in your file to sections that are actually part of the project. The section we provided, 4B1Y1, matches up with the section we expect it to, demo 4B1Y1A. So that looks good. Click OK to move to the next dialog here. And as you can see, we have a start depth of 0 and an end depth of 0.8. That's good. I'm not going to worry about options. Those were described in the section depths demo 7A in more detail. So check that if you are confused about any of these. So I'm just going to choose a destination file. Let's call it simple sit. Click export. It happens very fast because it's a very, very simple strat column to export because it consists of a single section. And as you can see, close this now. I'll zoom out a little bit here. It's of course very, very huge. But as you can see, we have a single section here, half of which is this biosiliceous ooze, I believe, and the other half of which is this diatomaceous ooze. So that is what we would expect to see from this very simple splice interval table. And as you can see, the legend has been created. It contains all the lithologies and the symbols that were part of this. Also note that in our section in PSICAT, there were these two symbols here, lights, but both of them are above the 10 centimeter mark. So they were excluded from the strat column here because they were not in the range that we specified. Similarly, this wavy bedding here was below 90 centimeters, so it too is not part of the strat column. So that was extremely simple. Now let's do a slightly more complex example. Let's see, here we go. Okay, so now we're going to add portions of, or the remainder of core 1. So we're going to add parts of sections 2 and 3, and we're going to do that in a single row. So as before, our core is 4B1Y. But this time we're going to start in section 2 at 50 centimeters and continue into section 3, stopping just below the transition to phosphatic rock at 75 centimeters. So we're starting in this section at 50 centimeters, so right here, and we're going to continue into section 3, and we're going to stop just below where it transitions to this phosphatic rock. So you're just going to see mostly this sandstone, I think it is, and a tiny portion at the bottom of this phosphatic rock because we're just going to take the first 5 centimeters of that. And that occurs at section depth 75. So we're going to that's the bottom of our interval. So now all we need to do is fill in our CSF and CCSFA values. And as always, they will be the same value. In this case, we ended our previous interval at 0.8 meters total depth. And we want our new interval, to abut that interval. So we're going to start at 0.8. And this interval is 50 centimeters plus 75 centimeters, so 1.25 centimeters in length. So that gives us 2.05 to 2.05 meters here. So that's one interval, and then we're going to add another interval that pulls from the sections of core 2, 2y1 and 2y2. So again, 4b, but now it's core 2, type is still y. We're going to start in section 1, and we're going to take all of section 1. So we're going to start at 0, and again I'm going to leave CCF and CSF blank for a moment. We're going to start in section 1 and take all of it, and then we're going to end this interval in section 2, and we're only going to take the top 40 centimeters of it, so we'll end at 40 centimeters. Until now, we've kept our total depths contiguous. Where interval number 1 here ended, we started our second interval. But there's no requirement to do this, so we do not have to start this interval at the bottom depths of the previous interval, which was 2.05. For instance, we can create a half-meter gap in our strat column by starting this interval at 2.55 meters instead. So we're going to do that, just to demonstrate that that is possible. And we have a total of 1.4 meters of material in this interval because we're using all of section 1, which is a meter long. And we're going to use the first 40 centimeters of section 2, so that's 1.4 meters, which added to 2.55 should be 3.95 centimeters, if my math is correct. Or sorry, excuse me, 3.95 meters, not centimeters. So now we have a slightly more complicated splice interval table here. It will have 3 intervals, the second and third of which are actually pulling from multiple sections. This one is pulling from both section 2 and section 3, and this one is pulling from section 1 and section 2 of core number 2. So let's save this again. Call it V3. Now we'll return to PSICAT. Export a strat column based on that. So choose V3. And as you can see, PSICAT took our 3 rows of data and correctly, for the second and third row, realized that more than one section was being referenced, and it figured out what the project sections that corresponded to those metadata sections are. So as you can see, all 5 of the sections being used here match up with project sections. That's good. If you don't have a match that you're expecting, the first thing to check would be the accuracy of your core ID elements in your splice interval table file. But we're correct here, so I'm going to click OK. And once again, we're going to have a longer stratigraphic column here. Again, I will not worry about the options, so we're just going to export this trickier set, trickier strat column. Okay, and I export this. Again, it's very quick. And now, if we look at this, hopefully we'll see what we expect to see. So, as before, we took all but the top and bottom 10 centimeters of section 1, core 1, section 1. So that's present here, and then we moved on to section 2 and section 3 of core 1. We took, let's refer back to my file now. Okay. So for our second interval, we took the bottom 50 centimeters of section 2 here, and we took the first 75 centimeters of this section. So again, we should see mostly sandstone and a tiny smidge of phosphatic rock at the bottom of that. So there's our salt from section 2, and there is our sandstone, and there, as expected, is our tiny sliver of phosphatic rock because we stopped at 75 centimeters. And then you can see we have a half-meter gap, which came from the fact that our bottom depth for the third interval, or sorry, our top depth for the third interval was a ½ meter below the bottom depth of the second interval. So that's why that space is there. And again, we took the entire contents of Core 2, Section 1. As you can see, that matches up there. We've got this gypsum followed by some sandstone. And then we took the first 40 centimeters of our second section in Core 2. As you can see, there it is. And because you can also see that this symbol was included in the strat column, because it is in the range that we decided to specify in our interval. So those are the basics of constructing a sit by hand. In general, you're not going to need to do this, but I thought it was a good way to illustrate how exactly PSICAT creates a strat column based on a splice interval table as opposed to a section depth file. The main difference, again, being that with a splice interval table, you can choose the intervals that you want to include. With a section depth file, PSICAT will always include the entire contents of the section, regardless of how you specify the intervals. So that's it. Thanks for listening.